The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. We still have a few minutes until we'll get this off and running here, but just wanted to welcome you to the local agency Bridge Preservation Outreach Working Group. And like I said, we'll give it a few minutes for folks to pile in at the last minute. I find myself just staring at the ticker, watching the attendees rise. It's a good thing.
Yeah. Waiting for it to slow down.
Right?
Oh, we already have our first question. Good morning, there is no sound.
It seems like
we're broadcasting sound. Yeah.
I can hear you. Aaron, can you confirm that you can hear us?
Yeah, I can hear you. I think you probably just weren't talking yet. So, but
oh, okay. Now it says I can hear you.
Oh, okay.
Somebody
good.
else said I can hear you. So, lots of people are chiming in. They can hear us. That's good.
Okay, that's good. That's good. It reminds me of when I was leading the Western Bridge Preservation Partnership, and I would ask for volunteers on something, and then there would be silence afterwards, right? Because nobody volunteered.
Nobody.
But someone hit me up once, and they go, "I think my audio's broke. Like I hear you ask for stuff, and then nobody responds back." And I'm like, "No, that's just because nobody said anything. But since you're here."
Yeah, sounds like you want to help out.
Yeah, you have now joined the working group. Congratulations.
Right. I was just about to say it looks like the attendee number is leveled off, but it just started jumping again.
Most of my content are, PowerPoint by photos, so it'll go pretty quick.
Mm-hmm.
So I think we'll be okay if we give it another minute or so.
Yeah.
Still get people out early.
We can probably get started with the introductory stuff.
Yeah, let's do it.
My name's Jason DeRuver, bridge engineer at HDR, co-chair of the local agency outreach working group. Come from a background of structure maintenance with 20 years at Michigan DOT in structure maintenance, just venturing out near the end of my career into other things, but still have a huge passion for bridge maintenance. I'll be beginning the presentation with just a high overview of why we scope and kind of what kind of decision tools are out there for what to do when it's beyond maintenance crews. And then I'll be passing it over to Travis Kinney, who can introduce himself right now.
Yeah, my name is Travis Kinney. I work for David Evans and Associates. I'm the other co-chair to this local agency working group. I got 16 years of experience doing bridge maintenance, repair, preservation. Most of that experience was at Oregon DOT. And like I mentioned, now I'm at David Evans and Associates. A few more housekeeping things. The presentation is being recorded and will be made available shortly after. It usually takes them a couple days to get it uploaded somewhere. We have a question window. If you look at your app, please feel free to start typing in questions. If Jason and I don't catch them as we're presenting, we'll make sure we at least write our response back and send that out later. And I'll be doing the second half of the presentation. So with that, I'm going to kick it back over to Jason to go ahead and get us moving here.
I'm going to turn off my camera since it'll just look weird because I won't be looking at my camera. Let's see here. All right. Just confirm for me real quick, Travis. You can still see my presentation?
Yep, looks good.
All right. All right. So like I said, so this is kind of, so we have a bridge we're looking at and it's beyond what our maintenance crews do. So now what do we do? What are the decision tools that we have out there? Quick outline for my half of the presentation, or my 1/5 of the presentation. I'm just going to go over a few definitions and the deck-driven methodology for decision making that Michigan DOT uses. So like I said, today we're going to be talking about rehabilitation and replacement. I believe at a previous webinar, we've talked about within this group, we talked about maintenance bridge scoping in May of 2024. That presentation should be somewhere on the bridge preservation website. And in that presentation, we talked about what kind of things you can do for cyclical maintenance and condition-based maintenance, and just to kind of refresh people's memory, or if this is new to you. So when we're talking about bridge maintenance scoping, we're talking about, data collecting from the bridge and identifying activities that should be done before before major damage happens to the bridge or major deterioration, and kind of integrating those strategies into your day-to-day activities. And like I said, that was from May 2024. We can always, it's always good to talk about that. We could always talk about it again in the future, but that's not what we're talking about today. Today we're talking about in bridge asset management strategies, rehabilitation and replacement, primarily focused on some deck rehabilitation strategies. So why do we scope? Scoping, all agencies are supposed to have an asset management plan. At least all state agencies are supposed to have an asset management plan. Example in Michigan is we have a Michigan Transportation Asset Management Council. For the local agencies, they develop a statewide local agency asset management plan that kind of all the local agencies roll up into. Is to kind of establish funding goals, life cycle forecasting of all of the assets in the state, as well as investment strategies and providing monitoring triggers. This is how the Michigan Transportation Asset Management Council kind of develops the the asset management process. You can see they start off with, condition goals that they would ideally like to have and deadlines for those goals and how they're going to measure them. And then scoping is very important because scoping plugs into the asset management life cycle here with the inventory and condition data collection. So scoping is involved in that. Scoping is also part of that is the data analysis that comes into play. It comes into play in the life cycle analysis and forecasting. So that's all part of traditional, what I would call bridge scoping. That inventory collection is the site investigation, and then you take all that data as part of your scoping process, and you develop plans for your asset management from there. So we're talking about bridge rehabilitation today, and the FHWA defines rehabilitation as major work required to restore structural integrity or safety defects. So you can see here, this stuff is beyond maintenance that I'm showing. We've got holes in decks. We've got holes at the fascia that are impacting the strength and integrity of the bridge railing. We've got deterioration of the reinforcement that is attaching the bridge railing to the bridge. So, I mean, what do we do when we find out that we have something that's beyond maintenance? How do we address it? I just thought this would be a funny slide. We can go to the bar and double fist beers our problems away. We could bury our bridge in sand and hope nobody notices what's wrong with it. Or we could, in the bottom right picture here, set up a barrier wall and some sandbags and hope we get to it before it collapses. So in Michigan's developed the Michigan Bridge Deck Preservation Matrix. They have one for uncoated and they have one for coated reinforcement. It's very easy to find, available to anyone in the public. All you need is the internet search term Michigan Bridge Deck Preservation Matrix. And then if you're looking at a bridge deck that's uncoated or coated reinforcement, it's got separate matrices. What I'm showing here is the uncoated matrix. That is our decision-making tree for, okay, what do we do? We've got all our scoping data together, and now what are our options? So in the top half, the top third of the scoping data, it's really a deck-driven decision matrix. The other parts of the structure are kind of ancillary to that for the decision matrix in Michigan, and it's all based on condition state. A lot of if-then boxes. If your condition of the top surface is greater than or equal to a 5 in your deck rating, and then there's the then statements. Okay, well, then our deck bottom surface is greater than or equal to a 6 and has less than 2% deficiencies, we can do an epoxy overlay. If it's greater than a 5 and we still have less than 10% of DLAMs in the top, and our deck bottom surface is greater than poor, which is a 4, you can still think about doing a deck patch. And then this matrix also gives like an anticipated fixed life. These are where you're going to do your maintenance and your contracted maintenance type of projects. Continuing further down in the deck matrix is where you get to bridges that are in worse condition. And Travis is going to go over some case studies and some better identification of that. But this matrix is really great for just a visual representation of what your condition is and what you can anticipate. So for example, you have a bridge deck top surface that is a 4 or a 5. Your deficiencies are between 10 and 25% delamination in the top. That's probably more than you're going to want a deck patch. You start looking at, okay, my deck bottom is in still really good shape. I can do a deep concrete overlay. That's going to restore my top surface to an 8 or a 9. And I'm going to get a fixed life in Michigan of 25 to 30 years out of a deep concrete overlay. And let's say my deck bottom is worse. Let's say it's 10 to 25% deficiencies in the deck bottom and 10 to 25% in the top. You know, you could do a shallow concrete overlay, or you could do an HMA overlay with waterproofing membrane. In Michigan, the only time we do an HMA without a waterproofing membrane, and the only way you can get it programmed, is if you're just looking for, this bridge is shot, but I need some ride quality to get me through 2 to 4 years to the deck replacement. So I don't know if Travis is going to cover the difference between a deep and shallow concrete overlay in Michigan, or if other states do deep versus shallow. In Michigan, a deep concrete overlay will fully expose your top mat of reinforcement and pour new concrete to encapsulate that. Shallow concrete overlay isn't going to get that deep. It's more of the deck bottom is in kind of bad condition, and we don't want the hydro demolition to have too many blow throughs. So we might be exposing a little bit of the reinforcement, but we're really only taking off like the top 2-inch driving surface. So that's the difference between a deep and shallow concrete overlay. I've been using this deck preservation matrix for at least 25 years. It's been around longer than that. It's a really great tool for an asset manager to decide which direction they want to go when they're deciding on their deck repair options. I always want to take a plug for other rehab items. We could talk for possible future topics at this every other month webinar we're giving. We could talk substructure repair, superstructure repair, and scour, but that's not going to be part of today. And what I mean by that is these are rehab jobs where you're going to want to contract them out, but it's not necessarily a deck-driven decision. So you can see here we've got in the left, we've got a cantilevered pier cap with a tremendous amount of concrete missing and exposed reinforcement. Then we've got another pier cap with a very deep stall exposing reinforcement on the right. You've got substructure projects that could undermine your bearing, like is indicated here. More than 25% of your bearing is undermined. You're probably going to want to do temp supports before you're doing your substructure repair. Always consult an engineer before removing concrete from a substructure, just to check with them. Superstructure repair, I mean, there's a lot of different things you can do. Concrete beams can be carbon fiber wrapped. Some people can do that with a maintenance crew. Some people contract that out. This picture is one of our maintenance crews installing that carbon fiber wrap on a bridge beam that had been mildly damaged from an overheight vehicle. You can also do steel repairs to beams where you add a lot of steel plates and reinforcement to the steel beams to repair section loss. So that's another topic we could have in the future. And then lastly, scour repairs. Do you have bridges that are flashy? Do they have existing scour mitigation that has failed, like these gabion baskets in the picture that have failed and washed away? So just other things that we can discuss. I'd love to have anyone put any of that stuff in the chat for me for future interest in topics. And with that, I'm going to stop sharing my screen.
Yeah, Jason, we did get one in the chat that was a pretty good question that I don't know off the top of my head. Does your epoxy overlay provide a condition benefit in the SNIBI deck condition coating? And I am not sure. On
deck coatings, that is almost a state-by-state debate on whether or not it all comes down to what state you're in and how your state bridge inspection engineer program manager wants to count an epoxy overlay. It's very open to interpretation. I've heard lots of arguments on that. So that is a great question that doesn't have a specific answer because it is very vague, I will say. Is that kind of what you were thinking too, Travis? Or
I was just going to say, if I was paying for the overlay, I would make an argument that it has some benefit. And if it's addressing the deck cracking, I would argue that there's a benefit, but I think it's something that you'd have to work through.
Yeah, I mean, in Michigan, we count it as improving the deck surface rating. So in Michigan, it does count. Okay. But you also have to understand that a lot of times before you do a thin epoxy overlay, So if I remember, you're going to do deck patching, and then you also have to look at the fact that when you're doing the element rating, there's an element for unfilled cracks and an element for there's a rating for unsealed cracks versus sealed cracks. So I would argue that those cracks are now sealed by the epoxy overlay. They're covered up. They're not going to be leaking anymore. So there is a element benefit as well.
Okay. I'll buy it. Okay, so just confirming you guys are seeing kind of the title slide here, Bridge Decks Beyond Maintenance.
Yep, that's working.
All right, let's jump into it. So this first slide is just kind of hammering home again on the difference between what a rehab project looks like, which we actually are focusing on today on the left, and a preservation project on the right. And unfortunately, the bridge on the left probably didn't get those easier preservation type projects at a timely, a good time in its life. And so it deteriorated to the point where you didn't have a choice to just go and do one of those nice thin epoxy overlays. You had to go and do something more invasive. So just kind of highlight as you're seeing the presentation today on what the rehab looks like. If you start to think, boy, it sure looks like a lot of work, then try and focus on those nice looking bridge decks on the right and focus your assets on, or your resources on getting out to those decks and keeping them in good condition. Any good bridge deck project starts with the condition assessment. You can review existing inspection data, right? So the data that's already readily available to you. You can look at your condition trends, right? See how the bridge is changing over time. And then you can do some more in-depth inspections and testings to kind of fill in some missing pieces there. So here's an example of existing bridge data over time. And this is actually for a bridge that's going to be our case study at the end of this training. I've highlighted, so that bottom axis is, the year. So it goes all the way back to 1982 when it had its first data available. And this one, I guess I cut it off at 2022. And I highlighted in red, just kind of overlaid there, the deck rating specifically, because this slide shows deck, superstructure, and substructure. And this is, we're talking about decks in this training today. And you can just see as that, over time, this deck just started dropping in condition until it reached all the way down to a 4. It was probably not far off from getting to a 3 if we didn't take action on it. We took action, and then it jumped back up to a 6 on the condition rating with the deck rehab project. NDE, so non-destructive evaluation. This really helps fill in some missing pieces. Some of the most common methods that I've used in projects is acoustic sounding, and that could be something fancy that's a truck mounted rig, or it could be just something as simple as a person with a chain, like you can see in that top photo. GPR, ground penetrating radar, is used to look into the concrete. It's very useful for getting reinforcement depths. And then you can even, based on how the signal attenuates, start to do some deterioration modeling and looking at, is the material around the rebar starting to deteriorate? And then chloride testing. So salts in our bridge decks are bad. They get there from all kinds of different sources, usually applied by the folks responsible for maintaining the bridges, and it's usually part of a de-icing operation. But whether it's mag chloride or actual salt, the whole thing is that you're getting chlorides down to the rebar, which causes the rebar to corrode and fall off the concrete. And to test for that, you can take a core, pull that concrete core out, and then you can do some testing on it and figure out, how deep have those chlorides actually penetrated into the deck. So as you're looking at your bridge decks, this is our case study here. You start to think, how bad is the bridge deck, right? On this one, it doesn't take a genius to look at it and go, you're probably looking at a rehab project, right? Like, I don't need a lot of fancy testing to tell me that. The wide extent of patches on patches on patches will let me know that this deck is clearly beyond its service life and is in need of some repairs. However, some of that NDE testing that I mentioned can help tell me, how bad is it? So in this case, it was a chloride contamination at the rebar level. We did some NDE testing on this to see, well, how deep is the rebar and how deep did the chlorides penetrate? Kind of give us an idea of how much removal we might be looking at doing. I would just flag on this one here that the poor maintenance crew was going crazy with having to come back and patch this over and over and over. You can see the black cold mix asphalt patching material that was starting to go down. Clear indication that that crew has given up and is telling the rest of us this is beyond maintenance, someone help. Okay, NDE can help you again fill in those missing pieces. This is an interesting bridge that we're working on currently in Astoria, Oregon, and it's a long bridge, and if you look at it, the bridge deck that's closest to us looks kind of like a bombing range. And then if you look at beyond that line I just popped up there, the deck was in great condition, right? And so here you are, you got the same bridge built at the same time in the same exposure and environment. I got one part of the deck that's falling apart and what's going on with the other part of the deck. We did some scanning on this bridge deck, and what we found is that the reinforcement depths changed significantly. So this is just kind of a chart that shows your a box and whisker plot of reinforcement depths, but you can just kind of see here visually that right at that joint, there was a big jump in reinforcement depths. They got good clearance on one side of that joint and very poor clearance on the other. So that was a construction defect that led to that very significant jump in serviceability. Acoustic sounding. So this is just was done with just going out and dragging a chain across the deck. Can start to lead to some conclusions on it. So all that circled area, which is almost the whole right side lane there, is indicated that it's delammed. So the concrete has split the reinforcement level, and we would expect it to eventually pop off under traffic. Interesting enough, the other lane is in great condition, very few spalls on it. We did some discussing with the maintenance, local maintenance crews there for some more information on, could they help us explain why one side's so bad and the other's looking quite better. And in this case, what we found out is the mag chloride tank, the shed that holds that, is on one side of this bridge, very close to it. So when the icing truck was leaving the shed, they were full and applying mag chloride. And when they were on their way back to the shed, they were off and empty and didn't put mag chloride on the other side. And so it made a huge difference in how that deck was performing. When it comes time to do your deck preparation, you kind of start with the least invasive, the fastest and the cheapest, and you work your way down to the most expensive and the slower. So I kind of have the different deck preparation actions listed here. You basically have stuff that's just really meant to clean the deck. So shot blasting and pressure washing. You have some isolated concrete patching, which would be kind of expected on many bridge decks. It kind of more falls into that maintenance realm where you're maintaining the bridge deck. You can prep it for lots of different overlay types fairly cost effectively and quickly. And then you get down to that next kind of grouping there where you actually need to remove structural concrete or start doing some removal with specialized equipment. And once you get down there, you're looking at milling, selective hydro demolition, which I think Jason would call shallow hydro demolition, and then deep hydro demolition where you're getting all the way down to that top mat of rebar. Just some visuals of what this looks like. Here's an example of a shot blaster that's working on a deck that was in really pretty good condition, prepping it for an overlay. You can see there the swath of the nice bright, clean concrete with exposed aggregate in some spots, and then still the dirty surface without the exposed aggregate where it hasn't already made itself pass. Deck patching, we've done a whole training on deck patching, on concrete patching. There's lots to cover here, but this is just kind of an idea of it. If you find yourself patching most of the bridge deck, it's a good indication that patching is not going to be your solution. It's just a temporary repair. If you're doing small quantities and using good prep, then it's very likely that you fixed the problem, it was localized, and you can get some good service out of that deck. Milling, so this is when you want to remove material from the deck. This equipment is great in the sense that it gives you a nice uniform removal. You'll see when I get to some of the hydro demo photos that the removal is less uniform. It's really pretty quick. These machines can run across the deck really pretty fast. If you already have an overlay on the bridge deck, then this is almost always going to be your first go-to, because you have kind of a certain depth that you can go for and just remove it all off. If you're removing structural concrete, you got to think about putting it back. The biggest challenge with this one is if you have shallow rebar, this will find it. And so you have to be very cautious with locating your reinforcement first. As-built plans are helpful, but definitely I found wide variation in how things are actually built versus what the plans say. So find that rebar first, otherwise the contractor will find it for you. Okay, so selective hydro demolition. So this would be that shallow one. It's really more of a deck prep method where you're maybe only setting it to remove a 1/4 inch of concrete. The thing that's great about this is that it'll prep your good concrete with just a small amount of removal. And if you get to some really pretty poor concrete, then it'll scour itself down and remove that bad material. So that's why it's kind of considered called that selective hydro demolition, where the idea is that if you have certain bad spots, it'll get those, and then the rest of it that remains should be good, sound concrete. So this goes much faster than a deep hydro and provides just an outstanding surface for a cementitious overlay to go on top of. Okay, deep hydro demolition. I say this is your best option when your chlorides have reached the reinforcing level. I would argue that's probably actually your only option when it reaches the reinforcing level, right? You can't go and mill yourself down into the reinforcement. Once you need to remove material all the way around the reinforcement, then this deep hydro demolition is going to be your best bet. It is much slower, so from a cost standpoint, you don't want to specify this unless you have to. Going to have a lot of wastewater generated with this. The more concrete you remove in a single pass, the more likely you're going to have what we call a blow through, where you might actually have a bad spot and blow all the way through the bottom of the deck. So you want to be careful of what you're doing this over, right? Like you're over railroad tracks or sensitive streams or traffic, you might need to even think about potentially having containment installed underneath, or doing some isolated full depth repairs first. And then, it's difficult to get past the reinforcement. So the denser your top mat of reinforcement is, if you have like those negative moment areas at interior bents where you have just a pile of steel there, it's going to be really hard to blast down below it. So just know that that's going to take some additional work. So when to perform deep hydro demolition, if your deck is polka dotted like this, you got a ton of patching on it, then you'll know that that's probably a good candidate for that. The maturation's at the point where you really want to remove that whole top layer of concrete. And then if you have a high risk of those salts, those chlorides up at that top mat of reinforcement, would be a good time for that. Note that you're removing structural concrete, right? Especially if you're getting down to that rebar. So you want to be real cautious with how you're doing that. Sometimes these bridges are built on scaffolding and false work that until that deck is poured, the bridge is unstable. And so you could actually make a bridge unstable if you're not careful with how you're doing this. And then you need to replace the concrete you removed with structural concrete as well to go ahead and return that strength to the deck and maybe even the whole superstructure. I didn't want to just focus on concrete overlays here, so I just wanted to at least give a quick nod to all the different treatments that we have here. Those first 3 listed are more of a preservation-based or maintenance-based actions. Sealers, if your bridge deck is in good condition, just sealing it can give you some additional service life. You have thin epoxy overlays. Again, that's usually when your deck is structurally sound. Maybe it needs a new wearing surface, but you have a good deck to start with. Then you have PPC overlays, which have maybe a longer service life than those first 2. Typically, you wouldn't pair this with a deep hydro demolition because it's not considered a structural overlay. And then you got your cementitious overlays, and some of these have been around for a very long time, right? These concrete overlays have been a bread and butter, whether they're latex modified or higher least strength concrete or microsilica overlays. There's been a wide variety of them out there over time. But I kind of am lumping them all into two categories, where you have your more traditional concrete overlays that have that longer 7-day plus cure window, and then your high early strength concrete overlays that take off like a rocket for needing to return to traffic quicker. And either of them, depending on your staging, might work well with a hydro demolition. Okay, so we'll get to some good construction photos now. So this is a case study. That's the Yamhill Overflow Bridge. It was built in 1963. It's 300 feet long. It's only a 6-inch thick deck, so very thin, and it only was supposed to have been built with just 1 inch of design clearance. I can tell you for sure they didn't even hit that 1 inch in lots of spots. And it has actually a pretty high traffic volume. It's got 23,000 vehicles a day using this bridge. The bridge crew fondly, maybe not so fondly, referred to this bridge as the bombing range. I just love this picture on the left, patches on patches. The photo on the right just shows that exposed rebar, right? I didn't need to do a ton of GPR scanning on this bridge deck to figure out where the rebar was, because I could just see it in lots of spots. So we went out and measured it and found that the rebar was 1 inch or even less in many spots from the original design clearance. Our condition assessment, your bridge deck is in very poor condition, tons of patching. You have reinforcement less than 1 inch deep. You got high levels of chlorides. And what we concluded is that we really do need to remove 1 to 2 inches of concrete. So knowing that our reinforcement is only about 1 inch deep, we're doing what we would call a deep hydro, because we're trying to get below that reinforcement. So we knew what we needed to do to prep the bridge deck. We needed to pick an overlay to pair with that prep. Since we're removing structural concrete, we knew that we were going to either do one of our traditional concrete overlays or a high early strength concrete overlay. One of the other project constraints on this is that the deck is really pretty narrow, so staging it with 1 lane open wasn't very viable because of the traffic volumes and the workday commutes. The only permission that we could get for closures was on the weekend. So we needed something where we could get on a Friday night and be done by Monday morning. So that really limited us to only now selecting a high early strength concrete overlay as a viable option to repair this deck. So got some construction photos here that we'll just kind of run through the process. This is the hydro demolition unit. It's supported by water trucks and baker tanks to collect the debris. It's got a whole truck on a trailer that's got the pressure washer generation. This is a single nozzle straight line unit that runs at about 15 to 20,000 PSI. Just kind of another view of it. The unit kind of inches forward 1 inch or so at a time. It's all calibrated. You start off with, tweaking the adjustments to figure out what kind of removal you're looking at, or to hit your target removal depths. Let's see if we can play this little video here. So hopefully that played okay. Usually I have a rule of not putting videos in PowerPoints because they tend to struggle. But you can just notice that it just kind of goes back and forth and then advances one little space and then runs again. I would just note that there's a lot of debris that kicks out to the side as this thing is going through, because it really is just rubbleizing the concrete underneath it. Once it's made its way across, this is kind of more what your bridge deck will look like. You can see it's not necessarily a uniform removal here. You got some spots where the concrete was in really pretty good shape and didn't want to come out, and then other spots where it was, scouring down, and maybe we even found the bottom of the deck at some point. Some of those rebars that get partially exposed become problematic because it could be loose, and you want to get good concrete consolidated around it. And so they're kind of all in a line here, so it's hard to tell. But you have 1, 2, 3, 4, 5, 6, 7 folks running with chipping guns here, chipping around all the different reinforcing bars to go ahead and get us the ones that aren't sound, get some exposure underneath it so that you could get good concrete consolidation. So just a lot of labor to make that happen. Here they are still working on that debris removal. Just note that you're starting to get like a berm as they're trying to pile all that loose aggregate over to one side. Got all that wastewater to contend with. I'll kind of maybe direct your attention to that sandbag that's in the middle there. That was part of their containment plan for if they were to blow through the bridge deck. So they had a couple isolated locations where the deck was in just such poor condition that it just blew a hole right through it. So something to be paying attention as you're going. Again, I just highlight that, you get with this deck in such poor condition, you just get a highly variable removal here. And it's just a lot of work. It's really cool to be part of these projects. One, because you got a pressure washer that's just rubbleizing concrete. That's fun to watch. And to just watch the deck take that transformation of just removing all that bad concrete and getting it prepared. But boy, it sure takes a lot of folks working at it. They use fire hoses and they use pressure washers. That photo on the right, you can see they're starting to get down to a much smaller pile of debris that's left. But you really want to get it all off, and you want to be careful not to let the deck dry during this phase, right? You have all that kind of latent concrete, or that all that water with the debris and slurry in it. You don't want to let that dry on the deck because it'll make a weak surface and then something that you have to still clean back off. So really keeping at it with a large crew to keep it moving. This whole prep phase took about a day for one side of the bridge deck. Once the surface is totally prepared, it's totally clean, and they kind of go through and blow it off to remove standing water. You want to keep it damp, and then you want to you went through all that work of getting it clean and prepared. You want to protect it, so they roll out plastic over the top of it. And then they'll kind of roll that plastic back as they put their overlay down. For these high early strength concrete overlays, I know that they could go down with the bid well. However, in my experience on the projects I've been involved with, the contractor is almost always, or has always, submitted a request to use a rolling screed instead. Part of their logic is that these are short-term closure windows, and it takes a lot of time to set up the bid well, and that these overlays cure very rapidly. The total time from placement, wet cure, and pulling the blankets back off is just 3 hours. So that initial set doesn't take very long either. And so they just thought that a roller screed gave them a little more flexibility to do that. And on the overlays I've worked with, we have gotten good ride and performance with them, so I haven't had an issue yet. Here they are. They're just kind of pulling that blanket back right in front of it. You can see they don't have a ton of material right in front of that roller screed. They're staying right there and keeping it moving. For the projects I've been involved with, they use a on-site batching truck. So this is a mini mix truck where they have all the water and cement and aggregate all on site together and mix it right there in the chute and then place it right there. So I think you could use a mobile mixer on these. You just have to make sure that you're using the right retarders on it to keep it from taking off too quick. Here they are. This is just kind of another construction photo, working their way through, heading towards their bulkhead at the end. And then here I got a little video. The process goes quick. So they were from one end of the bridge deck to the other. By the time they got to the end, they were ready to start pulling the blankets off and open it and kind of work their way back through. So it only took them maybe 3 hours total to get across the bridge deck. The finishing of these kind of concrete overlays is very similar to any other concrete. You just float it, and then we use a tine finish on it. You can come back later and saw cut it if that's a preference, or the saw cut tining into it. The wet cure, we felt like it's pretty important on these to get the wet cure down. So the blankets went down right behind. The spec said within 15 minutes of the material being placed, you'd have a blanket on it and keep it saturated. Since it's only a 3-hour wet cure, we don't really have a plastic coating that goes down on top of these like you'd see with a more traditional 7-day cure. You just kind of have someone manning some hoses and just keeping it saturated as the 3 hours go off. You see here above any joints before you open it to traffic, you want to get down there and saw cut through the overlay so you don't have a weak plane to break it through. And then here you can see that they're already pulling the blankets back off and getting ready to open the roadway to traffic. So some things to note. My biggest concern with these high early strength concrete overlays is that when they take off like a rocket, you get shrinkage cracking, and I was worried that we would have a cracking everywhere and that it wouldn't perform well. In Oregon, we've been doing quite a few of these high strength overlays. Again, 3-hour wet cure. And then open to traffic after that. And gosh, they have been performing really well. We have not been seeing very much shrinkage cracking or really cracking at all in them. They've been wearing well. I know ODOT teamed up with Oregon State University to do a research report on it, where this is one of the early, this actual case study was one of their early examples that they did. They pulled cylinders from for some testing back in their lab. And that should be published soon. I checked in with ODOT here just recently, and it sounded like it was the final comments were kind of being resolved, and hopefully it'll be published in the very near future. But this went down during 2020, and so we got 5 years of service so far, and it's just performing really well. Okay, so with that, we're at the end of our slides, and we got some time here. Let's see, do we have any questions, Jason, that we need to address?
I have a question for you, Travis, and I apologize. I was answering a lot of questions if you covered it and I missed it. What do you do with the runoff water from the hydro?
You funnel it straight into the river. No, I'm kidding. It all has to be contained. So what they'll do is they'll set up sandbags and blankets and funnel it all down to the low point on the bridge, or run it off there, and then they'll pump it all off into a baker tank, where then it'll let it settle, and then they'll dispose of it. So there's a lot of disposal requirements. All the drains are plugged, joints are plugged. You know, that runoff water with that concrete slurry is very hazardous. It's very important that that be maintained as part of the project.
Yeah, I wanted to ask that question because we've had issues where our slurry water has tested at a pH of 13, which is a hazardous material. So
yeah, no, you definitely want to maintain it. The risk of blow through is a tougher one to address. You know, usually what you would do is I would inspect the bottom of the bridge deck, and if you start seeing alligating, kind of the alligator cracking, map cracking, heavy efflow, kind of those signs where, boy, you know, this deck looks bad all the way to the bottom, those might be a good indication that you would want to flag those spots for a full depth removal before the hydro demolition operation to kind of hedge your bets there. As part of the work, the contractor is required to submit a plan for, in the event of a blow through, what is your plan for containing the material, right? And so that's often, you know, we're going to sandbag it, we're going to get scaffolding in underneath to form the bottom side or something like that. But I have not been involved in a project where we've like put containment under the entire bottom of the bridge deck. We haven't felt it was necessary, and I think it would start to make the project cost prohibitive.
I think in Michigan we'll put in some like just some plywood false decking over traffic lanes just as a precautionary in case it shakes loose a piece, but I don't think we do anything else.
Mm-hmm.
Another question was, let me see, do you put a bonding agent on the hydro demolished surface prior to placing concrete?
Our specification calls for doing like as part of the concrete placement to get a kind of a concrete slurry right in front of the screed and broom it in. What I found is that the prep surface is so roughened that you don't really, it doesn't work all that well. And so often there isn't really any kind of an additional kind of screeding being done. So no, but definitely no bonding agent. The hydro prep is just phenomenal. It gives you such a good roughened surface of sound material.
Let's see. How wide are the hydro demolition machines?
I think the units would vary quite a bit. The ones that we were using, in fact, I had a slide that kind of showed one of the passes going through on it. But I would say that they're, so this is a 12-foot or a 14-foot bridge deck, and so it's in that 6-foot range. Yeah, this picture in the lower right corner kind of shows where the units made one pass through. You have that middle strip is the original deck material, and then on the right is where we've already done the deck placement from a previous weekend closure.
Okay. If there's any more coming in here.
I see a question. Where was that case study located? So this is in Oregon.
Let me see.
I got a question that was shot blasting for epoxy overlays, remove tining, or just give it a good cleaning for adhesion.
I answered that.
Oh, okay. Yeah, just cleaning.
No.
You want to get your
thin
tining off?
epoxy overlays. Well, I answered it as a either or. It depends on how the tining was installed because the epoxy it bonds to the aggregate. So if you're installing your tining to the wet concrete on your deck with a rake, it'll push down the aggregate substantially from that surface. So you'll want to make sure you just have a sufficient exposed aggregate. If we're going to have a thin epoxy overlay failure in Michigan, it'll be because they didn't remove the tining.
I guess I don't get a lot of bridge decks with good tining on it that I'm doing epoxy overlay on. Usually that's been worn off with our studded tires.
Oh, but we don't have any studded tire. Well, we do have, it does work on snowmobile trails. We'll thin epoxy overlay shoulders for that, so.
I see a question on, do we add cover over the rebar with that last one? And yes, the answer is yes. We wanted to increase the clear cover since it started with an inch or less. We went back with a thicker overlay. I think we had some concerns with overall grade changes impacting the substandard rails. And so my recollection is that we tried to remove like an inch to 2 inches and then go back with 4 inches so that we would get a 2-inch overlay, kind of a grade change at the end.
Travis, did you blast clean the rebar?
The hydro demolition itself does a good job on cleaning the rebar, so there was not a separate like sand blasting process.
Was there anything different in your quality control processes when you're batching on site versus getting it from a supplier?
The mobile mixing trucks, all of them have to go through a calibration process within some time period before. I want to say it was the week before placement. And then I think the QA, QC, like the rate of cylinders taken and the testing performed, followed our standard procedures for concrete placement. So I don't think it had additional cylinder requirements, but that could have changed since then. Like I said, we've just had great success with them. I was really apprehensive that this would work out well, and all of them have just been performing fantastically.
Why did you batch it on site though?
Why did we? It wasn't a requirement. It was how the contractor's means and methods. There's just a company that does that on-site mobile batching in Oregon that has been doing, to my knowledge, all the overlays, these high early strength ones, that is. Talking with the supplier at CTS, he's assured me that that they can use a more traditional mobile mixer or a concrete truck to place these. They just have to kind of put it to sleep first to time the drive to the project site.
Yeah, I think in Michigan, most of our contractors doing overlays or a lot of our contractors that do overlays have mobile batch plants.
These mobile mixer trucks, they kind of got their start doing lots of like residential small quantity stuff, and then they've really found their niche on these high early strength concrete overlays.
Yeah, all of Michigan's maintenance crews have their own, or all of the lower Michigan maintenance crews have their own mobile mixer as well, just for deck patching even, because it's such a small batch. Let's see.
We had one question here that was, after the hydro demo and placement of concrete, if the deck is showing longitudinal and spiderweb cracks, what would be the reason and any recommended solutions to fix it? I'm not a concrete materials expert, but I would be pointing toward shrinkage cracking. And once it's already cracked, the solution is to seal it. And as far as avoiding the cracks in the first place, I think it would be engaging with your structural materials folks to take a harder look at either your procedure for prepping the deck, for curing the overlay, and or for mix approval. But I know with like the microsilica overlays, we struggled with that. We always, in fact, it got written into the specification that, you know, contractor, before you leave the project, go seal the deck because we know it's going to be cracked. But since we moved on from those microsilica overlays, it seems to be performing much better.
Yeah, there is something to be said about how long between the concrete is placed and finished and getting it covered for the curing. If that surface dries out at all, you're going to end up with a lot of cracking.
Yeah, and so for a lot of our overlays, we've gone away from tining altogether and instead go back and saw cut the grooves, just for that reason of, you know, the only reason not to get your blankets down quick is because you'll lose your tining. And I was pretty adamant with the crew on site that I don't care so much about the tining. This is just a long straight shot. Get those blankets on. Okay. We just got a few minutes left, and it looks like you've, oh boy, I'm scrolling down and finding more. Thoughts or experience with E5 concrete? I guess I'm not familiar to that reference unless that's the high early strength latex modified ones.
Or is it the soybean concrete in Indiana? If they could expand on their question, that'd be great.
Yeah.
What would you recommend for removal of a 5-foot wide elevated bridge sidewalk where a hydro is too wide to access? I mean, my answer would be remove this, just remove the sidewalk.
Yeah, if the sidewalk is on top of the deck and not structural, then that would be where I would head to.
If it's not integral either,
yeah. I will say that there's some much smaller hydro demolition units, so it would be possible to use a smaller unit. If it's an overlay on the sidewalk and you don't have rebar, then there's also like the smaller roto mills that are like attached to like a bobcat device. If your sidewalk's strong enough to support it, you might be able to just mill it off.
Okay.
Do you grind and groove these repaired areas at a later date? We've done it both ways, where we either tine it during the process or we come back and do the saw cut tining. Answered the batch question. Oh, does increased dead load become a factor in the and the deck thickness. And yes, you do need to check your load rating. These are considered structural overlays, so you can take credit for that that top flange deck compression block getting bigger, but you do absolutely need to make sure that your additional dead load is not problematic if you're going to a higher or thicker grade when you're done. If you're and also with those grade changes, you need to be cautious of your bridge rails. If you already have substandard bridge rails, making them shorter with an overlay can be problematic.
Mm-hmm.
Okay. This group is fantastic on questions. Oh, yeah. Following completion of the hydro demolition, do you need to complete further partial depth removals with chipping hammers? And we do. I'll say one of the challenges we've had with that is tracking it for payment. At one point, we were trying to pay it by linear foot, but like there was, 10 people running around with chipping hammers and one inspector. And so it was, like how many feet of removal did you do? I'm not sure that we've gotten to a good answer on that. A lot of the contractors that bid it just put it at a penny because they budget the labor elsewhere and other bid items and struggle with also like how are we going to actually track this for payment. I think that gets us all of our questions, and we're right at our time. I would just encourage those that are still on the line to type into that chat window any suggestions you have for future presentations. We want to make sure the content we're providing in these trainings is very useful to our audience. And with that, I'll also put in a plug for previous presentations we've given. I saw one comment on, it would be great to do a scour repair presentation. We've actually done one. And so we'll make sure we get a link sent out as in addition to this video, a link to the library where you can see other videos that this group has put together.
Stuart does have the link to all the videos in the chat, so they should have access to that.
So thank you all, and enjoy the rest of your day.
All right. Thank you.
Okay, I think we can, for the recording. And it might be